right, so just picking up exactly where we left off. You guys will probably want to get a calculator for this, because I'm going to show you how to do it, how you would write your answer without a calculator, and then how to use your calculator to get what the exact answer would be. Mad dash to the calculators. Okay, here we go. So we have been converting from exponents to logs and logs to exponents, and we're going to still do that here. You just want to remember that whether it's written or not, what is ln actually saying? Log base e. So that's actually saying log base e of x equals 2. So how would I rewrite that? E squared equals x. Now, in a situation where you would not have a calculator, that would be your answer. This is actually something that we can compute, so I want to make sure you all know how that works. So again, on your calculators, you have two places where you can find the e. Above the division and above the ln. I only ever use the button above the ln because it's actually one less total button to push. I want to just show you, if I use the button above the division sign, do you see how that button, that big box is down? Let me show you what it does if it's the other one. That big box is up. So I like using the other one because it forces us to have an exponent right there. And usually with e's, we always have exponents. So I'm going to put e squared, and there's my answer. We're going to take that out to, how many decimal places do we usually do? So that's going to be 7.389. Beautiful. So if you had non-calculator part of a test, you would write your answer like this. Okay? If you would write it like this. Okay? Sometimes we can solve these problems without a calculator, though. And by the way, ladies and gentlemen, you don't have to go to this step here unless you really, really, really want to. So can anybody skip this step and tell me what this would look like in exponential form? E to the x equals 1. 0. And by the way, if I were to type into my calculator ln of 1, I get 0. Okay? Do it with or without a calculator with something like this. So this is going from a log to an exponent. Now we can go from an exponent to the log. How would I rewrite 14? If you want to write it with the base, if I were to do log base e of 5 equals x. If you need that step, there's nothing wrong with it. You just have to remember that this is never going to be accepted as a final answer. You will lose points if you do that. What do you need to say? ln of 5 is x. And again, this is something you can calculate on your calculator by simply typing in ln of 5. What would we have? 1.609. So I want you all to do number 15 for me. And I'm really funny. I always write my ln's as an h. They just kind of merge themselves together, and I have to really think about not doing that. Okay, so what do you get for x? Beautiful. Michaela, that was a funky look. Okay. Okay. All right, write down 16 and 17 for me. This is going to be it, and then we are going to go into the classwork part of this. Just write it down. It's okay. I expect a right now. I'm going to show you kind of the roundabout way to solve this, and then I'll tell you what you can always use. All right? If we're looking at this, I can set this equal to x if I don't know what this is telling me to do. And ln is actually log base what? So I have log base e of e to the 7th. If I were to rewrite that, I would say base exponent equals. What would x be? It's okay. Base exponent, or actually I should go the other way around for my circle. Make it a little easier to see what I'm talking about. Base exponent equals. Sorry about that. That's an equal. Okay. So x is 7. Likewise with this one. If I set that equal to, I'm not going to use x. I was going to use x, but x is in that problem already. I'm going to call that y. And I would rewrite it in logarithmic form. I would say base of equals. So log base e of y equals ln of 2x. What's another way of writing log base e? ln. If these parts match, those parts match also. And your answer is just 2x. I'm going to show you something really kind of cool, rather than coming out and saying it. Are you starting to see something? Do you see what I'm talking about here? Sometimes it's easier if I point out a whole bunch of examples, but what I want you to see with all of this, the bottom log with that matching base. Log matching base. Bottom log matching base. Bottom log matching base. Bottom log matching base. Log with a base matching a bottom. Whenever you have that, can you tell me what happens? Yeah, these guys literally drop away. They cancel out and all you have left is that number right there. Which is why, for this problem, ln e to the 7th is just 7. E to the ln 2x is just 2x. And if you're still confused with that, that's okay. We're going to go over this quite a bit because next class we're going to be talking a lot about properties of logs. And so this is like the first little property. It's just something I wanted you to get a taste of. So I had asked you guys to bring your textbooks with you. And for those of you who are like, ooh, I'm going to write this down, don't worry about writing this down. This is in the calendar that I gave you guys last class. It's already written down. You should already have it. But right now, what I'd like you all to do is to do this classwork. It should work pretty quickly. I expect every single one in here to finish these problems before you leave. Log and exponent problems like this tend to go very fast. But your classwork is in your textbook. I have a couple books in the back if you need to use one. You're welcome to work together, but you got to finish and turn this in.